Good morning, dear students of St. Joseph's International School of Primary 6. Today's video, we continue our discussion of the science curriculum for Primary 6, and this is going to be the start of the second concept in the second theme. So, in the last concept, the second theme, we were talking about thermal energy and matter. And we learned that thermal energy is what? It's the sum of kinetic energy inside of a matter. So it's the sum of the kinetic energy of all the molecules and the particles inside this matter. This way we learned a new thing about heat and how heat transfers. So this concept is about exactly that, heat transfer. So let's take a look at these two pictures here. This is a person holding a hot cup of tea or a hot cup of maybe hot chocolate or something. So how is the heat moving in this picture? From the hands of the person to the cup, or from the cup to the person's hand? In the second picture, this boy is feeling very hot once he goes on top of the slide. So what's happening? Is he losing heat or is he gaining heat? Well, we remember a very important thing, that heat always moves from the hotter object to the colder object. So in the first picture, heat is transferring from the cup of tea to the hands of the person. And similarly, heat is transferring from the slide, the hot slide, to the hand, to the body of the boy. That's why he is feeling hot. So, in this picture here, the lizard is basking in the sun. Basking means to stay in the sun, to chummas. So, the lizard is basking in the sun and it's getting the heat of the rock to its body, to keep its body warm. Same thing happens when we heat something, when we heat a pot. And when you heat a pot, heat transfers from the fire to the pot. So, let's try and answer these questions. Your hand may hurt if you hold the handle of the cooking pot. When you hold the handle that's usually made of plastic, does it burn or does it hurt or not? Well, it doesn't hurt. But if you touch the metal body, this part here of the pot, will it hurt or not? Of course it will hurt. So this teaches us that not all materials conduct heat or thermal energy the same way. So the same as we saw when we were talking about electricity, we have good conductors of electricity and bad conductors of electricity, or not bad. Let's call them good conductors of electricity and insulators, or electrical insulators. This is the same thing here. We have thermal conductors, which are good conductors of heat, and we have thermal insulators, which are bad conductors of heat. So, good conductors such as most metals, they are materials that allow thermal energy to transfer through them, such as iron. But bad conductors or thermal insulators, they are materials that resist the transfer of thermal energy. A very important thing to notice here. Thermal insulators do not stop the flow of heat, but they slow it down and they resist it, unlike electrical insulators, which stop the electrical flow completely. So let's take a look at this iron, this electric iron. The iron part conducts electricity it conducts heat, and this is how you iron the clothes. But the plastic part is a bad conductor or a thermal insulator, so it doesn't allow heat to transfer through it, and so you can hold it safely and you will not burn your hand. So let's take a look at these questions. The handle of an electric iron is made of metal. Is that true or false? That's definitely false. Second, the heat conductors are materials resistant to the transfer of thermal energy. True or false? That's also false, because they are good conductors, so they allow heat to transfer. Good. Let's talk more about the properties of heat. First, it's essential for life on Earth. It's very important for life on Earth. Second, heat flows from a hotter object to a colder or a cooler object only from the hot to the cold. Finally, for now, heat can't be lost, but it's only transferred. So when something becomes cold, this doesn't mean that the heat disappears. No, heat transfers from one place to another. So that's how it can get cold. So let's try answering these questions. Heat can't be lost. That's true. It only transfers from one place to another. Heat is a type of matter. No, it's a type of energy transfer. Heat is what kind of energy? Electrical or thermal? Heat is the flow of thermal energy. Heat can be transferred or lost. It can't be lost, so it has to be transferred. Good. Next, we continue talking about heat and how it transfers. So, I don't know how many times we told this by now. Heat transfers from hotter matter, from hotter objects, to cooler ones. And when this happens, we call this heat transfer. So let's imagine we have two objects, one hot and the other is cold. And they are in contact with each other. What happens? Heat transfers from the hot to the cold until they have the same temperature, until both are warm. When they reach this state, we call that thermal equilibrium. This means that both objects have the same temperature and they have equal temperatures. Good. And we calculate this temperature in this way. So for example, we have two beakers, one 60 degrees and the other is 10 degrees. And we mix them together. So you get the average of the two. So the temperature of the first plus the temperature of the second, and divide that by 2, which is the number of the beakers. So 60 plus 10, that's 70. 70 divided by 2 is 35 degrees. So this is the average temperature. But now, let's try and measure using a thermometer. Let's find the actual. And you see that it's 33. which is very close to the average. So if you don't have a thermometer, you can just use this theoretical way, and it's always going to be close to the actual temperature. Good. Now, let's talk about a very important thing. Maybe this is the most important lesson of the whole concept. And it's talking about the methods or the three different ways heat can transfer. First, we have conduction, convection, and radiation. So let's talk about each one of them. Conduction is when objects with different temperatures touch each other. So for conduction to take place, there has to be contact between the two objects. So for example, when you are having a fever and your temperature is high, you put cool pads on your head to lower your temperature. So this is heat transfer by conduction. So the heat transfers from your body to the pad because it moves from a hotter object to the colder object. And this happens for solids only. So conduction takes place in solids only, and it needs contact or touching. Next we have convection. So convection is the heat transfer due to the movement of the particles of liquids and gas. So it's unlike conduction, which used to be in solids only, this is in liquids and gases only. Good. So what happens in convection? Let's imagine you are heating this pot, and the first layer of water is heated. But now the hot water will move up, and it's going to be replaced by the cold water. So the cold water moves down. This cyclic movement, hot water going up and cold water going down, is what we call heat transfer by convection until all of the water inside the pot is the same temperature. So this is heat transfer by convection. It happens in it happens in liquids and in gases only, not in solids. Finally, radiation, which is the heat transfer through gases and space. Unlike conduction, this doesn't need contact or touching between the two objects for heat to transfer. You experience this when you put your hands close to a fire to warm yourself up. Also, we experience this every day when we feel the hot sun, and this heat transferred from the space to our planet, to Earth. So, heat transfer by radiation can go through gases, such as here, and in the space, such as the heat transfer of the sun, the thermal energy of the sun. Now, let's talk about what affects the speed of heat transfer. What makes it faster, what makes it slower? Three things. First, the difference in temperature between objects. As the difference increases, heat transfers faster. What do we mean by this? Let's imagine we have two beakers. One is 100 degrees, contains water that's 100 degrees Celsius, or let's say 90 degrees, and the other is 2 degrees. Of course, heat will transfer between the two much faster than if One is 10 and the other is 20. So the higher the difference between the two objects, the higher or the faster heat transfers. Second, the surface area of the object. As the surface area increases, the speed of heat transfer increases. Let's imagine you have a big bowl of soup and you let it in the air. And you have a small bowl of soup. Which one becomes cold or like cool faster? The bigger one. Why? Because it has more surface area exposed to the air, to the cold air. Good. Something else, the time of contact between objects. Remember the first example. We have a beaker that's 90 degrees and a beaker that's 3 degrees or 10 degrees. And you make them in contact for just 1 second. Does much happen? No, because it doesn't have time to transfer. The heat doesn't have the time. But if you let them touch for a minute, this means that heat transfers easily because it has more time of contact. A few information about heat is that the scientists that study the weather, which are called meteorologists, need to understand convection and radiation to help them predict the weather. Another important thing is that engineers must understand conduction, convection, and radiation to design new products such as cooking tools and to design sidewalks that are cooler and shadier. Good. We have already talked about thermal conductors and thermal insulators, so let's consider this as a revision. So the thermal conductors are materials that allow thermal energy to transfer through them, such as copper, iron, and aluminum, and metals in general. While thermal insulators are materials that resist or slow down the transfer of thermal energy or heat. We have many examples such as air, plastic, wood, glass, and so on. So let's see these two examples. We have the same temperature for water in both cases, but one bowl is metal and the other is plastic. Which one do you think you can hold in your hand? Obviously the plastic one, because it insulates heat. Good. In this case, we have a door knob and it has two sides, outside and inside, right? If you heat one side, you can feel the heat on the other. So this is an example of heat transfer. In the next video, we are going to finish our concept and finish our curriculum as well. So hopefully you understood everything, and as usual, if you have any questions, you can use the website and you can ask your teacher. Best of luck and see you next time.